Here's problem 47. The threshold wavelength for photoelectric emission of a particular substance is 500 nanometers. What is the work function in electron volts? Well, the frequency that corresponds to this threshold wavelength will be equal to the speed of light divided by the wavelength, 3 times 10 to the 8 over 500 nanometers, 500 times 10 to the minus 9, and that's equal to 6 times 10 to the 14 hertz. What does this mean? This is the threshold where electrons are just barely emitted. So if they are just starting to be emitted and they're just barely emitted, then the kinetic energy at this point is going to be 0. Well, we know in general that kinetic energy is equal to Planck's constant times the threshold frequency minus the work function. But in this case, if the kinetic energy is 0, where they're just barely being emitted, then our work function is going to equal Planck's constant times the threshold frequency. And that is going to be 6.626 times 10 to the minus 34 times this threshold frequency, 6 times 10 to the 14, and that is going to give us an energy of 3.98 times 10 to the minus 19 joules. But we want this in electron volts, so we're going to convert. We'll say that there's 1 electron volt per 1.6 times 10 to the minus 19 joules. So the 10 to the minus 19s cancel out, and we have 3.98 divided by 1.6, and that's going to give us 2.49 electron volts. So the work function for this particular substance is 2.49 electron volts.